Hey everyone, welcome back. In this video, we're going to go ahead and do an example that's going to help us get a little bit more practice using our logarithmic properties, and we're going to use them to kind of expand and manipulate some logarithmic expressions. So our task here is to expand this logarithm. So we have the natural log of the quantity x squared times y cubed divided by the square root of z. And so we're going to try to expand this logarithm as much as possible using our logarithmic properties that we've discussed so far. And so the first thing we can notice is, well, we have the log of a quotient. Our numerator is x squared y cubed, and our denominator is the square root of z. So the first property we can use is going to be our quotient property for logarithms. We can write this as the log of the numerator minus the log of the denominator. So the base is e, so we have the natural log of the numerator, the natural log of x squared times y cubed, and we have to subtract away from that the natural log of our denominator, the natural log of the square root of z. All right, I don't think we are done here. We can do quite a bit more expansion, because inside of that first logarithm, we still have a product, right, like m times n. So now we can break that apart as the sum of two logs instead. So our first logarithm can be broken apart as the natural log of the first factor, the natural log of x squared, plus the natural log of our second factor, or the natural log of y cubed. And now if we want to have an equivalent expression or equation here, we have to still subtract away the natural log of the square root of z. And so we've taken our single logarithm and now expanded it into 3 logarithms. That's as many logarithms as we can really break this into. Now that we have this broken into a bunch of individual logarithms, we can start bringing these exponents out of these logarithms as factors according to our power property. We couldn't do this at an earlier step because in earlier steps we had some kind of mixture of exponents. We can't bring out the 2 without also bringing out the 3, or at least affecting the 3. So if everything was raised to the power of 2 in this step, then we could bring out the exponent of 2, but that is not the case. So you cannot just bring out a single exponent at a time. It has to be the entire inside raised to that exponent if you want to take advantage of that power property for logarithms. All right, so let's go ahead and use that here. So the natural log of x squared we can rewrite as 2 times the natural log of just x, bringing that exponent of 2 out front as a factor. The natural log of y cubed can be rewritten as 3 times the natural log of y. And it may not seem like we can do anything with the natural log of the square root of z at the moment, but remember, the square root of z is the same as z to the power of 1/2. So if we think of it in that way, we actually can bring that square root or that power of 1/2 out front and rewrite that final piece as negative 1/2 times the natural log of just z. So here we have our final answer, our original logarithm, the natural log of x squared y cubed over the square root of z, expanded as much as possible. In its most expanded form, it's equivalent to 2 times the natural log of x plus 3 times the natural log of y minus 1/2 times the natural log of z. So when it comes to solving exponential and logarithmic equations, expanding and combining isn't going to be something we do very, very often. We will sometimes combine logarithms into a single logarithm to help us solve a logarithmic equation, but for the process of taking a logarithm and expanding it into several pieces or several logarithms, that's really going to be a skill that we take advantage of more in a calculus class when we're trying to do things like find derivatives of complicated functions.